substitution. When we did substitution with two equations, you want to take one equation and have it be x equals or y equals is what we always used to say, right? Well, now we need one equation that is x equals, y equals, or z equals. Those are your choices there. Okay? Now, these problems that are set up for substitution, they look a little bit different, don't they? Okay? They look a little bit different in that we don't have all the variables, which is why substitution is sometimes easier on these. I'm going to number them. Got my 1, 2, 3. What do you think? Which one am I solving for a variable? Probably equation 2.
Yeah.
And solve it for x. So I'm writing it down here so I can show the step. X plus 5y equals 9. To get x by itself, I'm going to subtract 5y. And x is going to be equal to, I'll be honest, 9 minus 5y works for me. Okay? I'm going to kind of box this, I think, so I can find it later. That is what I'm substituting. Now, in two equation substitution, you took that one equation, substituted back into the other equation. Here, I'm going to take this one equation and substitute it back into both other equations. Okay, so my equation 2 that I solved, I'm going to take it and I'm going to substitute it back into my other equations. So if I start with either 1, well, 1 and 3 both have to be done. So yeah, let's just go ahead and go with 1. So if I start with equation 1, which is 2x plus 3y minus 2z equals negative 1. Every place I see n x, we're going to replace with 9 minus 5y. So I'm going to have 2 times x, so 2 times 9 minus 5y. Keep the rest of the equation. Plus 3y minus 2z equals negative 1. From here, I want to solve this equation. Okay? I want to clean it up, have like variables on the left, numbers on the right. So of course, we're going to take that 2 and we're going to distribute. 18 minus 10y plus 3y minus 2z equals negative 1. If I want variables on the left and numbers on the right, there's two things that can happen here. What are those? Okay. Clean up like terms and move the 18, yes? Mm-hmm. So to clean up like terms, minus 10y and plus 3y. Can we do this all at once or am I doing too much? Okay. So negative 10y plus 3y is going to be negative 7y. We still have that minus 2z. Now, what about the 18? If it's a positive 18, I can subtract 18. Negative 1 minus 18, negative 19. Okay, guys, whether you like the looks of it or not, this is what I'm going to call equation 4. Okay, we're going to repeat the process now. So 2 was the one I solved. I just plugged into 1. And now I'm going to plug it into 3. So I'm plugging it into the other two equations. So let me write out 3, which is 4z minus 5x equals 4. Every place I see n x, I'm replacing with 9 minus 5y. So 4z minus 5 times what's x?
5 or 25. 9 minus 4y.
9 minus 5y for right now equals 4. Okay, clean it up. That minus 5 can distribute. Minus 5 times 9 is minus 45. Minus 5 times minus 5y plus 25y equals 4. Okay. Clean up. Okay, move that 45 over. Keep the variables where they are. So if I add the 45 over, I have a 4z plus 25y equals to 49. Now, one thing I will say, okay, so I'm going to call this equation 5. Now, last time I had yz, this time I have zy. It wouldn't hurt to flip them and say that this is 25y plus 4z equals 49. And here's my reasoning. From this point forward, I go back into the methods you were using with your elimination. So, well, we call this substitution because we start off with substitution. But now I'm going to take equation 4 and equation 5, and I'm going to work with them just like we did the others. Okay, so my equation 4 is negative 7y minus 2z equals negative 19. My equation 5 is 25y plus 4z equals 49. Your job is
Make this easy.
get one of your eliminate one of your variables. The obvious easier one is
7.
z. I don't really want to go for 7 times 25. Just saying. So if we're going to make the z's the same, what can we do?
Times the top times by 4 times bottom by -2.
Or
The opposite.
Multiply them by 2.
Can we just multiply the top by 2?
Well, I guess.
I didn't show any examples like this. I know I've had a couple of people ask me, can you do that? Yeah, you can just multiply one equation by something. Okay? Because 2 times 2 is 4, right? Okay, so my new equation 4, when I multiply by 2, negative 14y minus 4z equals negative 38. Keeping my bottom equation, 25y plus 4z equals 49. And we're doing what we've been doing, right? Negative 4z plus 4z, the whole point is they're opposite signs, we can add them and cancel. Negative 14y plus 25y is 11y. Z's cancel. Negative 38 plus 49? 11. Divide by 11 and y is 1. You guys know what to do here, right?
Find it pretty easy.
Take the y and put it into, usually we say 4 or 5, or there's another option here that will actually work this time.
2.
2 would make life real nice, wouldn't it?
Yeah.
Okay. I would use that at some point. So if we use 2, x equals 9 minus 5y. So x equals 9 minus 5 times 1. So x is 4, right? Now, normally at this point, what do we need? We need z, right?
Yep.
Normally we say go back to 1, 2, or 3. Or you could really use 4 or 5 here still too. It's not going to matter. Okay? What if I go back to,
Did you go back to
you want 4?
3? If you wanted to.
You could. Yep. You could go to 3 as well. There's lots of options. I'll go 3. Why not? 4z minus 5x equals 4. 4z minus 5 times 4 equals 4. 4z minus 20 equals 4. If it's minus 20, I'm going to add 20. 4z is 24, so z is 6. Ordered triples still? 4, 1, 6.
I think
Okay.
elimination better.
And here's what I'm going to say. It's a choice, right?
Yes.
I'll be honest. I prefer elimination. However, there are some times where elimination is not the easiest thing to do. And so then substitution is a better choice. Okay?